All right, part 2, number 3. Find the area of the shaded region in terms of theta. All right, we've got a sector. So do I have a formula for the area of a sector? Yes, I do, here on my formula page. 1/2 theta r squared. Area is equal to 1/2 theta r squared. I happen to know that r is 4, so area is equal to 1/2 theta times 4 squared. 4 squared is 16, half of 16 is 8. So area is equal to 8 theta. Bam, that's it. The area of the shaded region is 12. Find the value of theta. Oh, so now I can replace the a with a 12. So 12 is equal to 8 theta. So divide by 8, I get theta is equal to 12/8, and I can reduce that to 3/2 or 1.5 if you prefer. Okay, that's it for that. Next, the following diagram shows a square, ABCD, and a sector. Right here, OAB is a sector. It has a radius of 4. The area of sector AOB is 12. Oh, hey, this kind of looks familiar. 12, 12, AOB, AOB. Uh-oh, these are the same things. So I already know what theta is. Theta is 3/2 because we already did this work. Theta is equal to 3/2, and that's radians. Okay. Part of the square is shaded and labeled R. Okay, right here. First, find the length of AB. Oh, would you look at this? I have a triangle here, and I know this angle, and I know this is 4. This is also has to be 4 because it's a sector. So these two sides are the same. Okay, and let's see, what else do I know? I can figure out these angles because since this is an isosceles triangle, these two angles must be the same. Okay, in a triangle, the angles add up to 180 degrees. So it probably would have been easier if I had done this whole problem in degrees. So I could go back up here after I have the 3/2 theta, I could change that to degrees. But you know what? I'm going to be clever. I'm going to just do it in radians because I know that 180 degrees is equal to pi radians. All right? So 180 degrees is the same as pi. So I know this plus this has to equal pi. So I'm going to go ahead and call this x and this x because it's an isosceles triangle. So 2x plus 3/2 has to equal pi radians. So I'm going to minus my 2/2, so I have 2x is equal to pi minus 3/2, or I'm going to change that to 1.5 just so it fits better. 3/2 is the same as 1.5. Then to get x by itself, I got to divide everything by 2. So x is equal to pi minus 1.5 divided by 2. I'm going to do that on my calculator. So I have pi minus 1.5. And then I'm going to take that and divide it by 2. So that means that each of these angles is 0.821 radians. 0.821 radians, 0.821 radians. And I'm going to keep this number in my calculator in case I need to use that again. All right, so now what can I do? I have, what am I trying to find? I'm trying to find this side. I'm going to go ahead and call that, what should I call that? I'll call that Z. We'll call that side Z. So I have an angle opposite a side, and I have an angle opposite of a side, and I'm trying to find Z. Oh, I can use law of sines. Because look here, I've got I've got 2 sides and I've got 3 angles, so I can find the missing side. I can use my law of sines. So I'm going to use law of sines here. So I know that sine of 3/2 over Z. Oh, you know what? I almost forgot. I like to put my unknown on top. It's going to make it easier to solve. So I don't know what Z is. Start with that. I don't know what Z is. I do know the angle across from it. So sine of 3/2. Remember, I'm working in radians, so when we use the calculator, we got to be in radians. That's going to be equal to another side over the angle opposite it. So sine of 0.821. So now, to solve for z, all I got to do is multiply the right side of the equation by sine of 3/2. So why didn't I leave myself more space? Let's put it down here. So z is equal to 4 over sine of 0.821 times sine of 1.5. Or 3/2, whichever. All right, so now I just got to put that into my calculator. Okay, so I'm going to have 4 times sine 1.5. Notice I'm in radians, so I'm cool. And I'm going to divide that by sine of 0.821, which I have stored in here, so I'm going to go grab it. There it is. Always keep your numbers stored in your calculator if they're not exact. And that gets me z is approximately equal to, because I got to round it off, 5.45. So that is AB. AB is 5.45. Let me check my answer key, make sure I'm not messing up here. Where's my answer key? Yep, I'm good. Okay, so there is my side Z. Now, find the perimeter of the shaded region. Okay, so to find the perimeter of the shaded region, I need to figure out, well, what is the side length of this? Oh, I just found the side length. Z, since this is a square, if this is 5.45, then all of these are 5.45. So this is 5.45, this is 5.45, and this is 5.45. Okay, so the only thing I'm missing, oops, sorry, Mr. Alvarez just walked into my classroom and distracted me. Okay, so the one thing I'm missing now is I need this arc length. Oh, arc length. I have a formula for arc length. Arc length. Arc length is equal to theta times radius. So this puppy right here, I need to find this arc length. Arc length is equal to theta times radius. Oh, how easy is that? I know the radius is 4. And I know the arc length, sorry, theta is 3/2. By the way, all these formulas that I'm using, all these formulas here, right here, you have to be in radians for them to work. Okay, these have to be in radians. If you're using sine, cosine, and tangent, it does not. You can use degrees. But if you're using these two ones, you have to be in radians. You cannot do it with degrees. Okay, super important. If you do this in degrees, you get totally wacky answers, like really big. They don't make sense. All right, so 3/2, that's the same as 1.5 times 4. No, that's 6. I probably could have done that in my head. So the arc length is equal to 6. So that's this side. So my perimeter is, I have 3 of these, 3 of the 5.45 plus that arc length 6. Let's go ahead and add those together. 6 plus 3 times 5.45, and I get 22.35. So perimeter is equal to 22.35. Oh, 3 significant figures. Okay, I got to do that with, oh, actually I don't, was that perfect? No, I had rounded off. So, you know what, if I left it like that, it would probably be okay, but really it should be perimeter is approximately equal to 22.4 would be more specifically correct, giving 3 significant figures, because this was not an exact answer. I rounded that off to 3 significant figures, so then when I multiply it by 3 and add something to it, I still need to round it off to 3 significant figures, just to be on the safe side. So we get 22.4 centimeters. And there it is. All right, that was problem 3. That was a big one.